So, architecting for security in the cloud. This talk kind of came about as a result of my work on the simpler stuff. For those who don't know, I work at National Instruments. That's like my day job. I started this free open source risk management thing on the side, and all of a sudden people started coming to me and asking, can you host it for me? And it forced me to like create this whole new environment to basically host SimpleRisk for all these people who wanted me to do that. And the interesting thing is it forced me to look at things in a different way. Whereas at National Instruments, we've got the network all built out, we've got people who build these systems, and we've got standards for that, and we've got application admins and all these different things. SimpleRisk gave me, it was a challenge, but it was also an opportunity. It was like you're starting from a green field. You can do whatever you want. And it was a really good place to be in because I was able to make it as secure as I wanted. And I didn't have to listen to all the, the business talk about usability and all this other stuff. So I made it a little bit harder on myself, but at the same time, I made it a lot more secure. And so the talk is really based on how do you build something from the ground up with security in mind. So you gave me a little bit of an introduction. My little clicky thing ain't working anymore. That's great. There. So I'm an OWASP board member. I've done the SimpleRisk thing. I work at National Instruments, and if you want to tweet me, I'm Josh Sokol on Twitter. It's kind of funny. There's a couple other people on Twitter with similar names, and there's like an @Josh_Sokol, and he does some like thing for NASA astronomy. So I keep getting these tweets about, I love that paper that you wrote on, the universe. And I'm like, dang, I didn't do that. I think he gets stuff about cybersecurity too, and he hates it. So. When we're talking about the cloud is a very nebulous term, no pun intended. It really depends on whose shoes you're walking in, right? For those of us who works for companies and we're dealing with the cloud all the time, the cloud usually means a synonym for software as a service, right? It's some environment that somebody else handles for us, and we just throw some stuff up there, and it just works magically, right? But for a hosting provider, and for you guys as companies who are servicing others, it really means somebody else's data center. It's just another way for us to provide infrastructure that happens to be really easy to use, really quick to spin things up, and convenient, right? The challenge here was that SimpleRisk was really built as an internal use application at NI. It was, hey, we need you to start this risk management program. Hey, GRC tools cost about $500,000. Hey, we don't want to spend $500,000, so you write something yourself, right? And I had to, later on, I transitioned it to open source because I thought, hey, maybe some other people can get some use out of it. And then the whole business of SimpleRisk came as a result of people who didn't want to host it to themselves. They wanted that, the efficiency, the agility of being in the cloud, right? So in my case, rather than building out a whole data center to host 1 or 2 customers initially, it was, why don't I use Amazon, right? People talk good things about AWS, why don't I just move some stuff to there? And because of the data that's being hosted, it's risk management, security was a huge concern. I wanted to make sure that when I put this up there, it wasn't going to get hacked because, well, that would be bad for business, right? So, in terms of architecture, SimpleRisk. It's Apache, it can run on Nginx, it can run on IIS. Why you want to run it on Windows, I don't know. But it's interesting because we have people who there's WAMP. It's an actual software package, which is like Windows, Apache, MySQL, and PHP. If you run on Ubuntu, man, you can get SimpleRisk in like 15 minutes up and running on your system. If you run on Windows, it's like, back and forth, like, hey, I ran into this error. Yeah, that's because you're running Windows. The code for SimpleRisk is written in PHP. And I know what you're thinking, right? PHP, it's insecure, whatever. The fact is that I know PHP. It's something that I've been writing for a very, very long time. And really, PHP is as secure as the developer makes it. It uses a MySQL database backend. In order to show you this, I know I had to elaborate on this because you guys are a bunch of security practitioners and you're going to call me out on this whole PHP thing. White had did a report, they kind of showed like, hey, here's the number of vulnerabilities we see in each language, right? And .NET, Java, ASP, they're all 11. PHP was 7. Cold Fusion was a little bit lower. That's because nobody uses it. And then Perl here on the bottom. That's because they're all elite hackers and whatever. In 2015, White Hat actually came out and they say at present time we can say all the aforementioned items, language, industry, org size, dev process, they don't matter. And if they do, it's only slightly and under very specific conditions. So you're questioning the PHP thing, I get it. But in my case, it was a language that I was very, very familiar with, and so it was what I went with, right? And security is more about how well you know a language than the choice of any particular language. Make sense? Cool. All right, so for me, PHP, you have the same code, it works across multiple platforms. It's the reason why I can say that works on Windows and works on Linux and I can run on Mac and whatever. Doesn't matter. Installation of PHP, really, really simple, right? You just apt-get install PHP and it just works on Ubuntu. Maybe a little bit more complex in Windows. You download an installer and run it, whatever. There's lots of documentation. I think I've heard twice at this point about Stack Overflow and the problems on there. There are a lot of examples on Stack Overflow and whatnot. A lot of examples of what not to do as well. But in the end, like I said, I knew PHP better than any other language. And a little bit on me, my background, I'm on the OWASP board of directors. I've been doing AppSec for about a decade now and helping train our developers and things like that. So when I started working on the Simplest application, it was focused around the generic coding best practices. So how do I do input validation? I want to do HTML output encoding, use hashes and salts for passwords and things like that. Industry standard crypto, authentication and authorization. These are all the basics that you want to do when you're writing any sort of an application. And I'm not going to cover any of these into any detail, but I wanted to mention this because when you're architecting an application in the cloud or creating a SaaS platform or whatever, it starts with the application, right? You want to make sure that your application has security from the ground up in mind. You can't just say, well, I threw it on a hardened Linux stack and therefore it's secure, right? If there's a SQL injection vulnerability in it, the hardened Linux stack isn't going to make a difference. So what we're going to do here is we're going to kind of build that from the green grass, open field, and we're going to build up from there for today. The architecture then starts with that secure web application, right? We've written something that we know it had security best practices, coding best practices in mind. From there, we start off and we say, all right, well, how do we keep this updated? What do we need to do to make sure that our application is always at the latest version? It's we have the latest version and it's running and it's working and it's tested and all this other stuff. And the way that we do this is through automation. We use tools like Git and like Chef to make sure that these things are coming from a repository where we know we have access control over who can push changes to that thing. We have auditability, and so we can actually see, hey, this person pushed changes here, here's all the changes they push. We have auditability over what changes are made, and we have easy rollback. So, in the case of, I had some crypto stuff that one of my developers actually rolled into GitHub, and I looked at it and I said, this sucks, and I hit revert, and all of a sudden those changes were gone, and it was back to normal, right? It makes it really, really simple to kind of manage that. And alongside that, once you have the stuff in GitHub, or any other repository for that matter, you can use automated tools to say, hey, has anything changed here? If yes, then we go and we deploy this out. If no, you just leave it alone. So the servers know when code's made available. You have code that gets automatically rolled out to the servers then. And the nice thing is this minimizes deployment mistakes. You're not worrying about somebody SCPing files over to an environment and did they copy everything and did they remember or forget to make that directory that was required and all these different things that people make mistakes. Those are the kind of things that we don't have to worry about when all that is automated. It ensures that our server configuration is consistent. So if you're rolling changes, you can roll changes. You can have a dev repo and a production repo, and you can roll changes to dev. You can make sure that everything works out just fine. And then you say, all right, well, let's check that change into the production, and off you go. Yeah. So at this point, our architecture looks a little bit different. We still have our secure web application. It's running on a web application server. And then we have a couple of pieces that we've attached to this. We have the GitHub repo, and we have our orchestration server. And for anybody who didn't attend, I did a free full-day training a couple days ago for LastCon on the OWASP Top 10. And towards the end, because we had some extra time, we talked a little bit about threat modeling. And one of the tools for threat modeling is data flow diagrams. So if you guys don't have this in your environment, this is a really good tool to have. Draw pictures about what's going on in your environment. Understand where the data goes, where it comes from, and how it works in your environment, how it flows from one thing to another, because that's how you understand the problems. That's how you understand the security challenges that you're going to face. So if you see one thing talking to another thing, and that thing sits outside of the picture, well, that's probably a trust boundary that you have to address with some sort of authentication or authorization, right? So we've got our picture here. Now the next step, once we go from here, is really about server hardening. It's how do we make sure that our servers are up to date with the latest patches? How do we make sure that there aren't weird services and things like that running on the system? And for this, I highly recommend CIS, Center for Information Security. They have a number of benchmarks that they put out. Basically, for each different type of environment, here's what we think your server should look like. Here's how you should harden that server. And it goes through, and they've got checklists for turning off telnet. Most of our systems don't have telnet enabled by default anymore, but there are certainly environments where that can happen. It talks about host-based firewall rules and doing default deny. Well, if you do a default deny and then you enable little bits, it makes your application a whole lot more secure because there aren't people who can scan across an entire environment and see every single port and things like that. These the attacks that target specific things that you don't even use, you can kind of rule them out when you talk about attack surface because you've basically filtered them out at that host-based level. Now that doesn't mean that you shouldn't be doing firewalls, right? Everybody should have an actual firewall, but as soon as you start doing host-based firewall, you can do segmentation of different environments. You can say that this guy is only allowed to talk to this guy. You can do segmentation within the environment. You can cut out certain ports and protocols and things like that. So always make sure you're running host-based firewalls in addition to those external firewalls. And then the last little bit here is just kind of a tidbit. If you don't want to have SSH available to everywhere in your environment, what you should do is you should have a bastion host. Have one server that's like your jump server. If I connect to that server, then I can use that server to talk to everything else. It's a little bit of security through obscurity, but in my mind, it's actually a really good thing to do because what happens is you don't have to enable SSH connectivity from everywhere on all those other hosts. You only say, these guys can get talked to by this one person, right? And so by doing that, you're able to control access through that one host. You make sure that only the approved people have access to that host, and everything else, nobody can get to it, right? So it adds that little bit. So now in terms of our picture, we have this new Bastion host. The Bastion host only has SSH access in, right? So you're not like, hey, it's our Bastion host, but it also runs MySQL and it also does Nginx and whatever, right? We're trying to narrow the attack surface on this guy. So our Bastion host is SSH only, and it's SSH only out. Makes access control really, really easy. Now, we've got our database. I mentioned that SimpleRisk runs on MySQL database. And so there are some basic things that we do for MySQL database security. And these are the kind of things that it doesn't matter if you're running MySQL or Oracle or Postgres or whatever, you're going to have to do these things regardless. So the first thing is your database users, right? Your database users are the access token to get into your database. And most people, well, maybe it's a good question for you guys. Once you guys set a database password, think in your mind. Don't raise your hand because that would be bad. Think in your mind, do I change my database passwords after I set them, or have they been there for a year, 2 years, 5 years, 10 years, right? If you're doing password rotation, at least on an annual basis, hopefully way less than that, you're on the better side of this. My guess is, as you're thinking in your head, you're probably thinking more like, yeah, the last time we changed the database password was when we created it. I think that's very common. It's probably not good. We want to make sure we're using long, random passwords and that we're changing them on a regular basis, right? Changing database passwords actually isn't too difficult, and there's some really good tools out there, privileged access management tools, where you can basically say, you as a tool now manage this guy. I want you to create really long, really random password and just update it on a regular basis. And they can even handle like the configuration files and things like that. For database permissions, this is, if you've played on the back of the badge, right? We've got this guy. This is the badge game. I spent a lot of time on this, by the way, so please do it. And I've got these really awesome challenge coins for everybody who completes it. So if you've done the game, one of the pieces on there has to do with databases. And one of the things is, depending on how you set your permissions, people can see a lot of information, or they can see a little bit of information. And you can also control with the database permissions what they're able to do. So this goes back to the concept, which is a very basic security principle of least privilege, right? Give a process only the minimum amount of permission that needs to do its job and nothing more. So when it comes to databases, if you have a process and all it needs to do is grab data from the database and it'll never actually write anything back into the database, then why would you give it insert permissions? It doesn't make sense, right? So for that particular thing, you give it select statements and nothing else. Or if you have a process and all it needs to do is write data into the database, maybe it's doing a log or it's inserting some order or something like that, it doesn't ever have to read data from the database. Why would you give it read access, right? So we have to think explicitly when we're writing these processes, these applications and things like that. We have to explicitly think about what we're going to do here. Is it necessary for me to grant all these different permissions, or can I give it a little subset of the permissions and not give it access to create new databases, create new tables, add permissions, those kind of things, because those can lead to additional compromises. The last bit here is restricting the host. And with database credentials, what you can do is you can say, this is local host only. Well, if it's local host only, that's probably a more secure way to do it, right? Because that means that nobody talks to the database from outside, but it doesn't really scale well. So when we have n-tier architectures, right, we have multiple web servers that are going to talk to the database, we need to be able to say, we have access from this host and this host and this host. The common way to do this is, in MySQL especially, is you just put a percent for the host name. And the percent is like a wildcard. It basically says, anybody can talk to this. But if you think about it, you don't want anybody to talk to the database, right? You really want just a subset of servers, probably 2 or 3 servers to talk to the database. You probably don't even want individual users to be able to talk to that database because that would be bad. So when you're setting up your database permissions, you go and you say, I only want this IP address to be able to talk to it, or these IP addresses to be able to talk to it. And by doing this, you're able to restrict access talking directly to that database to just the servers that you've created access for. And on top of this, you can add in that host-based firewall, and you can add network-based firewalls, so that you've actually created these layers of defense in depth so that only the things that you want are talking to the systems that you want. In terms of Amazon, AWS database security, they have this concept of security groups. And with security groups, you can create what's called an inbound access rule. And so with the inbound access rule, you have yet an additional layer of defense where you can say, according to Amazon, only these servers are able to talk to this database. And if you're not using this, you absolutely should, because this is going to restrict access to, again, just those application servers that you know are yours. Right? You're trying to minimize this attack surface, which means that your application is going to be more secure. And lastly, don't make databases publicly accessible. Again, if you're doing my badge game, this is a little bit of a hint. There may or may not be a publicly accessible database there. Okay, so our picture looks something like this, right? Our architecture, we still have that web application server. We're still pulling data from GitHub. We're still using our orchestration server to tell it what to do. We've got our Bastion host. We've got SSH access to our orchestration server and web application server. But now we've added this RDS component, the Amazon piece, the database piece. But we've restricted it. We've restricted it to just MySQL, right, 3306, and we restricted it to only our web application server. Right? So we've got a very minimal attack surface here, and at this point, we haven't even added external network connectivity. Nobody's able to talk into our environment. Our environment is just able to talk to itself. Right? So I've mentioned it a couple times, so I wanted to kind of define it at this point. Attack surface. And if you're a developer, I know we've got a lot of developers at LastCon. We've got a lot of people who are kind of in the DevOps space. Attack surface is basically the sum of the different points or attack vectors where an unauthorized user, aka the attacker, can try to enter data or extract data from the environment. It's basically all the ways that somebody can interface with our application. And our goal in this scenario should be to minimize that attack surface. So if you look at that picture right here, we've got a pretty nice looking castle, right? But it's green field around it, right? There's some trees, there's lots of grass. If I were going to attack this guy, I'd break a window, right? I'd walk right in there. If I'm going to attack this guy, man, I don't even see any windows on that thing, right? We've got a huge moat around it. Interesting side note, I learned this the other day. I was doing some research on castles. I know that sounds weird. Moats, most of us think that moats are to prevent somebody from crossing over to the castle, right, and attacking it that way. It's actually to prevent people from tunneling under the castle or tunneling under the walls, because you got this huge body of water above it, and if somebody tries to dig underneath it, the tunnel collapses, it fills with water, and kills everybody who's trying to tunnel under it. Interesting side note about moats, right? So the ways that these castles are built is they have multiple layers, defensive depth. They usually have big doors, and they have these portholes where people can shoot arrows and dump boiling oil and all this fun stuff. It's meant to minimize the attack surface, minimize the ways that somebody can get into that facility, and to defend people and prevent attack, right? So right now, if we were to look at our application, our attack surface looks something like this. We've got a whole set of environment that's in our VPC, our virtual private cloud. This is at Amazon, right? And that includes our Bastion host, that includes the orchestration server, this includes our web app server, and the database server. And we've done a pretty good job of isolating that entire environment from anybody else getting to it, right? We have this other piece which kind of sits outside of that. And right now, we haven't given any web connectivity into this environment. So our attack surface is basically my Amazon console and GitHub, right? And if somebody can compromise my GitHub credentials, then they have access to that repository, they can change my source code, and they can push stuff into my environment. Okay, so I know I have to protect that guy. If they compromise my Amazon console, then they have access to my servers, they can start and stop shit, they can modify configurations, remove firewalls, and whatnot. Now, from a defender standpoint, what you should be looking at is, okay, if that's my attack surface, then those are the things I need to harden, right? And so when it comes to GitHub, I should make sure that I'm using multi-factor authentication. I should probably be going in there and making sure I have long, random passwords, kept in a secure password vault. In terms of Amazon, again, multi-factor authentication, secure password vaults, and whatnot. So we're basically creating this is where an attacker is going to get me. How do I escalate the level? How do I make it more secure so that somebody can't get into that environment? The other stuff, at least right now, we've got security in place, but we're creating these layers and we're understanding where somebody's going to try and get me. So the next step here, I mentioned we don't have access, right? Nobody can talk to our environment at this point, which is a problem if we want to do business, if we want to actually have customers and things like that. And we also need to enable access for an administrative account, people to be able to do things in this environment. So we add a remote user. We've got somebody coming in from the internet. We've got our Amazon console still. We still have GitHub. And then we have our whole environment. So really what we've added here is we've got this internet piece. And the internet piece is like the biggest attack surface there is, right? We've got lots of adversaries on there, tons of attack vectors, lots of different ways. But because we've architected this in this way, we're able to limit how much they're able to do. As it sits right now, we need SSH access into our Bastion host, right? Somebody has to be able to get to that. But we've got this little bit of security obscurity. You have to be able to find that and know that you're looking for it in order to be able to talk to anything else in that environment, because that's the only one that's publicly accessible. And then we have the load balancer piece here, which is we have effectively a proxy server that is going to talk to our environment, and then we as the internet user can talk to the load balancer. And what this does is it actually restricts that attack surface, right? We are only allowing HTTP or HTTPS to the load balancer, and then only that HTTP or HTTPS traffic is passed directly on to that web application server. So we're limiting the number of ways that somebody can get at this. All right. The other good thing that the load balancer does here is you have a single, effectively, front end for the internet, and then you can have as much as you want behind this. So if you're trying to scale, you can have multiple web application servers, right? And the load balancer just talks to each of those, and then that talks to the database. And then you can do things like Amazon has a concept called multi-Z, or availability zone, for the RDS instance, where your database or your application server writes to the database instance, but it's actually writing to multiple database instances. So you can build in the availability and the redundancy there. It doesn't affect the attack surface at all. All that's inside, the attack surface is outside. And as we look at this, we can easily identify these are the things that we feel like we've done a pretty good job of securing. We've architected it properly, so we feel pretty good about this. These are the things that we have to be extra diligent about. We've got to monitor them very, very closely, because these are the ways that an attacker is going to get into our environment. So now, coming along with attack surface, we have this idea of attack vector, right? The attack vector is basically, how is somebody going to get into my environment? And in this case, when we start looking at this, we've got a few that kind of bubble up, right? We have this idea of somebody with inside access, somebody who has extra credentials, where they're able to compromise the confidentiality, the integrity, the availability of our application. We have this idea of somebody compromising Amazon, and they change the configurations in the environment. We have the idea of an attack vector where somebody compromises GitHub, and then they push malicious code into the environment. Or the attacker finds a vulnerability in the application in order to gain access, or they find a way to access the Bastion host. We can very clearly list out all of the possible threat vectors, the attack vectors, the different ways that somebody's going to attack our environment. And what this means is we can take this a step further, and we can say, all right, how do we plan mitigations against each of these attack vectors? So that's what we do. We look at the insider threat, and we say, all right, well, how do we combat an insider threat? You know, one is you don't hire people you don't know and can't trust, right? You want to make sure that they have background checks, that they're vetted to be a part of your organization. And the second is you limit people who have access to your environment, right? I don't want people to be talking to my servers if they're not qualified to do so. Do they have a system administration background, or are they going to write rm-rf/ and go, whoops, right? We want to make sure that they're qualified to do that, and we want to make sure that only the right people are accessing our environment. In terms of Amazon, we want to limit the users who have access. This is probably an additional step up. Not everybody who has admin rights on a server needs to have admin rights in Amazon, right? They don't have to have the ability to create and delete firewall rules if all they're doing is looking at logs or provisioning files or accounts or whatever, right? We can limit who has access to this. And one of the nice things with Amazon is you can do additional role-based authorization. So you can use their IAM facilities and say, James Wickett actually had a talk about this, you can use different authorization capabilities within Amazon to say, these users can do these things, these users can do these things. And if you bucketize those users in terms of what they can do, you're significantly restricting that attack vector. You're making it so that there effectively has to be some form of collusion for them to do anything, right? Again, long and random passwords, you have to enforce password policies, and you can do this via policy in Amazon as well. And then you can require multi-factor authentication. Say that all of your users have to have a second factor of authentication, and what that does is it prevents somebody from compromising a password via a phishing attack or something like that, shoulder surfing, and then just being able to get into the environment, right? You make them, not only do they have to do that, but they also have to hit you over the head with a mallet and grab your phone, right? And then know the password for that device as well. In terms of GitHub, it's kind of the same thing, right? We want to limit who has access, we want to ensure good passwords, we want to require multi-factor. The only other piece that comes in with the GitHub, and honestly this is probably part of Amazon as well, is we want to audit the changes. We want to know what's happening in our environment, and we want to make sure that these things are happening with the right cadence, right? Are we making sure that we're, the right people are touching the code? If there's somebody who shouldn't have access to our environment, we need to know that, and we need to alert on that. If it's something where Somebody's inserting new code, let's check it. Let's make sure that they aren't pushing cross-site scripting vulnerabilities or SQL injection vulnerabilities into our application. So we need to make sure that we're doing routine code reviews there. Then we have our web application. So web application attack surface, even though it's like 1, maybe 2 ports, is huge. It's one of the biggest attack surfaces out there. And if you look at like the Verizon data breach report, like year after year, web application attacks are huge. It's one of the biggest causes of a data breach, and it's certainly one of the most dangerous ones, right? We have a lot of damage that comes out of these web application attacks, because even though it's coming through one port, one protocol, it's actually a lot of data that sits behind there. And one SQL injection attack could basically spoil the entire database, right? You get all the data out of there. So we need to make sure we're doing things like the OWASP Top 10. There's going to be a new release of OWASP Top 10 coming out here in a couple months. Use HTTPS by default. Interesting trade-off here with HTTPS. If you're using HTTP, you can see pretty much everything that's going through the application. You can log it, you can look at the request parameters and all that stuff. If you move to HTTPS by default, you have to figure out a way to break that. And that might mean that you front with a load balancer, you do the decryption there, and then you do inspection after the load balancer. It might mean that you have to, in some way, you basically have to figure out how do I get the data unencrypted so that I can look at it, right? Secure HTTPS configurations. You can go to sslabs.com, and there's a test that you can run on SSL Labs. Plug in your domain, and it'll go through and it'll test to make sure that it's got a valid SSL certificate, that's CA signed, that has a proper hash, not a MD5 hash, not a SHA-1 hash, that has a proper hash. That all the insecure ciphers have been disabled. That's not using TLS, SSLv2, SSLv3. It's using TLS 1.2. All these different things. Honoring cipher orders. It'll basically come back with a letter grade, just like you got back in high school, right? And it'll say you got an F and you need to fix this, or it'll tell you you've got an A and you're doing a really good job. And if you get an F, it'll say here's the different things that you need to fix. Everybody in this room, if you run a website that's publicly facing that uses HTTPS, if it's using HTTP, convert to HTTPS. If it's using HTTPS, run SSL Labs, know what your environment looks like, and then if you have an F, it's no big deal, fix it, right? It doesn't take that much time and effort, and there's lots of resources on it. Your environment should include some sort of intrusion prevention system so that you're looking at the data, you're doing kind of signature-based inspection for common threats, some rate limiting, those kind of things, and a web application firewall so that you're looking for things like that OWASP Top 10. You're looking for people trying to exploit cross-site scripting or SQL injection or things like that. So good application security is really how we're going to defend our web application. And then the last little bit here is remote access. For this particular attack vector, we want to use long and random passwords for our SSH users. You can do multi-factor authentication for SSH as well. There's decent PAM modules that'll basically do the multi-factor authentication. I played with one with a YubiKey where I can basically use a YubiKey and it creates a random seed, and that would authenticate against the Linux system for SSH access. So lots of decent things that you can do out there that probably won't cost you a lot of money to do it. Use key-based authentication for SSH users. So something a lot of people use a username and password combination. Well, we all know that phishing is out there, it's on the rise, and so the more of this phishing kind of stuff that we see, the more we're seeing people get their credentials popped. And the result of that is if their credentials get popped, and that's all I need in order to access a system, well, they just broke into your system. So one of the things that you can do, and it doesn't cost any money to do, is you can use key-based authentication. Key-based authentication still can be password-based. You can create passwords for the keys so that they're encrypted. But now when you connect to a box via SSH, not only do you have to be able to know the password and know the valid user, you also have to have a key to do that. So it gets back to the multi-factor authentication where you have something you know, the password, and something you have, which is the key. And most people wouldn't have that key even if they got the password somehow, so you're able to prevent them from SSHing to that box. Restrict what IP ranges are allowed to talk into there. So you can definitely say, like, only this range is able to talk to this, or only this IP is able to talk to it. And then disable SSH unless you're VPN'd into the VPC. So even though you have this concept of a Bastion host, and even though you're saying only these users can SSH to the Bastion, and then only the Bastion can talk to all these other hosts, if you create a VPN around your virtual private cloud, you've basically reduced that attack surface even further. So it's now not even just I can SSH to the Bastion host, so I can do a brute force attack and get the credentials for that and log in that way. It's I have to actually get into the VPN environment so that I can then talk to the Bastion host, so that I can then try a brute force attack, so that I can then go from the Bastion host to the other hosts in my environment, right? We've created so many layers here of defense that makes it really, really difficult for an attacker to do this, and chances are high that they're going to want to move on to somewhere else. It's like that slowest buffalo gets eaten, right? You don't want to be the slowest buffalo. If you're the slowest buffalo, you're going to go down. You're going to show up in the Verizon data breach report. You're going to be really sad. Twitters are going to go all crazy about you. And you're going to wind up like an Equifax, right? So recommendations here. When you're doing this, determine what is or is not in scope, right? There are going to be things in your environment where you're going to have control over it. And for those things, you're going to want to do this kind of threat modeling. You're going to want to look at the attack surface. And you're going to want to try and figure out where are the ways that an attacker is going to attack this and how can I make those better. Create that data flow diagram so that you know how your environment works, what pieces are communicating with each other. And that allows you to really reduce that attack surface, because you can say anything that doesn't follow these guidelines, I don't need it, I don't want it, and I'm going to restrict it. Identify that attack surface, identify the threat vectors, those ways that somebody's going to go attack it. And then once you know all this, once you have an idea of how your environment works and where somebody's going to attack it, then you can plan those mitigations. Then you can figure out, how do I reduce the risk of the threats in my environment? So with that, we've got time for Q&A. What do you guys got? Nothing. That was just so amazing, where I went so fast and I lost y'all, right? Yeah.
Thank you. Are you also doing disk encryption for data at rest?
So Amazon, you can do disk encryption, yeah. What we actually do, so the disk encryption piece, if you do the database encryption piece, they offer a database encryption. The challenge is it basically does the encryption on inserts and it does decryptions on select. And so if you handle encryption that way, what effectively happens is, like a SQL injection attack, it's going to do the decrypt on the select. So what we'll actually do, we have an encryption piece where it does effectively application server-based encryption, and then it inserts the encrypted data. So all the data that's being stored in the database is already encrypted with a key that is effectively a secure key. It's based on a combination of user data plus server data, and yeah. We do hard disk encryption for basically everything else. But in Amazon, it's not like you're going to take that hard disk and like walk off with it. So it's really the database piece that you need to worry about. That make sense? Yeah.
Sure. How do you back up your code?
Back up your code?
Yeah.
Well, your code's going into GitHub.
Right.
So you basically have a backup automatically there.
Okay.
That's really all you need to worry about.
You don't back that up again? I'm surprised.
What's that?
I would think you'd back that up again.
Well, I back up a lot of things, yeah. No, well, I mean, if you think about it, like if I have stuff in GitHub and I sync the GitHub stuff down to like my laptop as an example, I have a tool on my laptop that backs it up. So,
gotcha.
like it's probably getting backed up 10 different ways and I only know 5 of them, right?
Cool.
Yeah.
Thank you.
And since you're using RDS, database backup is probably happening automatically, right?
Yeah, database backup.
So you
we do
don't-
regular snapshots, we do daily snapshots, we keep them for 30 plus days, and yeah.
Okay.
Yep. Anybody else? That guy? No problem. All right, thank you guys.